Pseudoscience, fact or fiction? The term pseudoscience contains the word pseudo, which means artificial, and the word science, as I'm sure you already know. Sometimes we call pseudoscience fake science too. Pseudoscience refers to what appears to be science, but in fact isn't science at all. These claims often refer to non-existent research, incorrect or unreliable research, and tries to explain things by using a lot of scientific terms or claims that are too good to be true. As a result, pseudoscience is one of the most common types of fake news, or the most misleading fake news, because it often looks like science. Distinguishing between real and fake sciences is a very challenging task. In fact, people often ask, what's the difference between real science and fake science? First, real science requires reliable and accurate research to support a claim, while fake science often has no research to support it, or it has some research that isn't confirmed or internationally accredited. And even if it's internationally accepted research, the data may be distorted. The interpretations are different from real research. For example, let's say an article claims that a drug is the remedy for some disease, but in fact, this research came from experimentation on animals only. Secondly, real science needs to be clear enough so that it can be proved or can be refuted. For example, in physics theories, calculations are often done with a clear and exact number, right? Assuming that there are experiments, it appears that the results give us a different number from the theory. That theory can be refuted, revised, and improved. But pseudoscience is often too vague, which leads us to believe it's correct. Or, if it's wrong, there's always an explanation. For example, a product called quantum stones claims to treat backaches when placed on a person's spine. So, if you were to just put that stone on your back and hope for the best, your backache would quickly disappear. But if I claimed I used the product properly, yet still have a backache, the company argues I don't have enough faith. Really? How? Just like that. Real science can always be reproduced within the same conditional framework, while pseudoscience cannot. Or maybe it can work for specific individuals, or there is a relatively small sample group. Or the outcomes are good because of outside factors, and the results that are often claimed usually come from experiments that are not planned and designed thoroughly, which make them unreliable. Nowadays, there is a lot of pseudoscience shared on social media. One of the weirdest claims that drinking urine cures diseases. Many people are absolutely convinced that our urine has medical properties and can be used to treat a wide range of diseases. There are also many other theories too. One of them claims that drinking urine will help ease circulation of fluids in the body. Liquid in, liquid out. But there is actually no scientific research to suggest that urine has any medical properties. In fact, drinking pee can be dangerous for any person, since urine is often contaminated with toxins excreted from the body. In short, you shouldn't drink it. whether it's your own or someone else's, especially if someone claims it can cure a disease. Another example of pseudoscience is that people tend to think homeopathy can treat all diseases. Homeopathy has been a medical alternative since the 18th century. Its principle is that a disease can be used to treat diseases. Let's just say it's the principle of fighting fire with fire. The methodology of homeopathy is to dilute toxins or substances that cause diseases in a large amount of water, then mix and shake it until it's well combined, and then dilute it again with water and shake it up again until you get an extremely diluted solution, and it claims that the end result is a treatment for the disease. Of course, substances that are diluted as such may not cause any harm to our body, but it's actually not a treatment in any respect. A person who is treated this way might feel that his or her condition improves, but in fact, it may improve because of many other factors. The fact that a patient feels that they are feeling better and are unaware that they are receiving false or pseudo-treatment is called the placebo effect. Placebo effect treatments can range from taking pills made from simple starch or sugars, or saline injections labeled as medicine into a patient's body, or even pseudo-surgery, where doctors open the patient's skin without actually doing any treatment. The beliefs about homeopathy was widely accepted in the old days because drug efficacy tests weren't conducted well enough. But scientists around the world now agree that homeopathy is a type of pseudoscience, and it could even be harmful to patients, because if a patient has a serious enough disease and chooses to be treated with homeopathy, he or she may lose the opportunity to be treated with modern medicine in time. And now, the idea of homeopathic treatment is returning. It was even claimed that it can be used to treat pneumonia or even COVID-19. But there's actually no scientific evidence to support this claim. It's just simply a false belief. Another pseudoscience claim that many people have heard of in the news is the dowsing rod. It's used to find underground water sources, metals, or other valuables. Its principle is to hold a Y-shaped stick, or to hold two L-shaped metal rods in both hands, and then walk around. Whenever the rod bends towards the ground, or if the metal sticks lean towards each other, which indicates the object they're looking for is underground. It was often claimed that what makes the sticks bend towards the earth is some kind of energy. This concept has been expanded into many different devices. One of them is the sadly famous GT200, a device used to find buried explosives. Many people still claim that it actually works, but according to systematic research, it proved that this device does nothing but random guessing, and the fact that just because the metal sticks bend or move is only caused by muscle spasms by the holder. Another pseudoscience claim that many people may have heard of is that intelligence depends on the shape of the skull. A long time ago, there was a science called phrenology, a science that had been prevalent in England during the 19th century. It claimed that the shape of a person's skull is somehow connected to our intelligence, and they believed our personality, character traits, mental ability, and intelligence level were associated with the shape of our skull. This concept was widely applied all over the world. Scientists at that time used an image of the skull dissected into labeled sections or pictures of so-called experts using a device to measure the width and size of a child's head, and then assessing the future of that child. Nowadays, it is clear that phrenology is an absolute pseudoscience, and it's not medically recognized at all. But we may still see this idea in our society. There is an attempt to link various physical characteristics to the intelligence or aptitudes of children, but for intelligence levels, physical traits are quite irrelevant. Another pseudoscience that many people have probably heard about, since it's so famous, is the Bermuda Triangle, also known as the Demon Triangle. It was a science-based story that you may have heard of since you were young. It is an area on Earth when planes and ships that move through the area disappear or sink forever. The Bermuda Triangle covers an area off the island of Bermuda, the Bahamas, and the eastern coast of the United States. This theory became very famous in 1974 when Charles Berlitz wrote a book called The Bermuda Triangle. In his book, he told the story about the lost city of Atlantis, hidden beneath the Bermuda Triangle, which sent out a kind of energy to make ships and planes disappear. Millions of copies of the book were sold and translated into several different languages. Many years later, in 1977, the film Close Encounters of the Third Kind was released. This film was directed by Steven Spielberg, a very famous film director. Part of the story was about the discovery of a World War II-era plane in the Bermuda Triangle. This movie helped to make the Bermuda Triangle even more famous. But in fact, the Bermuda Triangle area has no more shipwrecks or plane crashes than any other areas on Earth, and planes can fly over the area with complete safety. We live in a time where pseudoscience is widely shared on social media platforms. So how do we non-scientific folk know which is real science or pseudoscience? The easiest way is to develop your critical thinking, which means how to think, analyze, and distinguish when we receive new information. When we hear anything that sounds too good to be true, it probably is. Think for a minute and compare the information with a trusted source. And more importantly, we should always seek more scientific knowledge. Because even basic scientific knowledge will help us determine which information is real science and which is pseudoscience.